I should start rather saying welcome and thank you for joining this demo. And before I can start the conversation on Linux, let me give you a brief introduction of mine as what I'm doing. So basically, my name is Musabuddin Sayed, and I'm a senior system admin where I have around 8.5 years, close to 9 years of experience in IT industry, where I have started my career as a Linux admin. Then I moved into Linux clustering, Linux virtualization. I worked on AIX very closely since 8.5 years, and AIX clustering, AIX virtualization, and as a part of my job, I also went into VMware like virtualization, in which I've dealt with some virtualization concept of VMware. And presently, my profile is as a cloud engineer, where I'm working on Cloud Portal, where we have worked on different type of cloud computings like OpenStack, Cloud Stack kind of thing. So this is what my professional career is all about. And as well as trainings are concerned, I am a very much regular trainer where I've been dealt in online trainings, offline trainings, classroom, corporate, almost all flavor of trainings I've delivered. And almost around or more than 300 batches I've done in all the respected things what I've taught. So this is what my small introduction that what I am and what I'm doing these days. Now let's try to talk on what you're here for, Linux. Like what is this Linux and how Linux came into the picture. I rather would like to show you a small story over here where we'll try to talk on the journey of Linux into the world. So in order to understand Linux, if I ask you that what is Linux, the definite answer would be it's an operating system. So if I ask what is an operating system, so a regular answer which is almost perfect. It's an interface between user and the hardware. As the hardware does not understand the human readable language, it works on binaries, and human could not understand the binaries. So in that scenario, we require a translator, we require an interface that can convert the hardware language into humans and humans language into hardware so that we can have a communication. And that's a perfect answer. But in order to understand Linux, we need to understand the anatomy of this operating system, like how operating system is built, and then we can understand this concept. And also in this webinar, as you see, I'm going to cover few important things out over here, like first, like just now we have understood what is an operating system. Then we're going to talk about how OS is designed, when Unix was introduced, how many flavor of Unix are there, one very important movement, GNU movement, invention of Linux, and flavor of Linux, and finally in which areas Linux is used in the current market. So as we have discussed what is an operating system, we have understood very well that it's an interface between user and the hardware in order to communicate from both ends. Now let's try to see that how an operating system is built. Now, when you say an operating system, the first thing that comes in my mind would be source code. And when you combine this source code with some applications, it is going to give you one of the most important part of operating system, which we call it as kernel. And when this kernel is combined with several software, it is going to give us our final product, which we call it as operating system. So basically, if you see source code are the set of instructions that are written in the programming language so that it may perform the tasks what user is asking to do or what user wants to do. So these source codes are designed in some programming language, let's say C programming language. So if it is a programming language like C, then definitely it may require some compilers, it may require some libraries and all. So those compilers, those libraries are available in the form of application. When you combine these two things, you're going to get the most important part of your operating system called kernel. Consider kernel as the heart of the operating system. See, if a human heart does not perform, then it is declared as dead. Then, in the same way, if the kernel of an operating system does not function, the OS is dead. And if the kernel crashes, the OS gets crashed. So, verily, the whole thing depends on the kernel. That's the reason it's the most important part. It is called as the heart of the operating system. And when this kernel is combined with various software, for example, listening music, I may go with VLC Media Player. For browsing internet, Mozilla Firefox, like that blah blah software, I'm going to club together with kernel and I'm going to get my final product, which I call it as operating system. So this is how an operating system is designed. Now you might be wondering that why am I talking about this thing? Because in order to understand Linux development, we need to really understand this thing. So let's talk about the first complete operating system of the world, which is Unix. Prior to Unix, we used to have some half operating system, punch card system, and all that thing. Unix was the one full complete operating system of the world. Unix was designed in AT&T Bell Labs, and earlier it was given. This task was given to Ken Thompson, one of the very popular scientists. Ken was the introducer or father of Pascal language, or in other words, we call it as B language. So when it was given to Ken, Ken thought that let me try to write the source code in Pascal language or B language, where eventually he failed out completely. That source code, what he written in Pascal, did not work for him. So what he did, he collaborated his work with one of the very, very popular scientist of all time in IT industry, that was Dennis Ritchie. So as we know that Dennis is father of C language, or the introducer or developer of C language, he suggested that why not to write the half code in C language and half code in B language, so that let's see that what things will work. The portion that was written in C language was actually successful. Then in 1969, they decided that let's rewrite the whole thing into C language. And they rewrite the complete source code in C language, and they have released the first ever complete operating system of the world in the year 1969, which they have named as Unix. At the beginning, Unix was not commercial. It was not popular either. So earlier it was given to schools, colleges, universities, so that people may see that how operating system is and how does it work. But slowly it started to catch the eye of industry giants, industry people, and they wanted to purchase Unix so that they can use it in their environments. But what this AT&T people have done, they have never sold Unix to anybody. Still Unix is the proprietary of AT&T. Instead of selling the whole operating system, what they did is they have kept this source code for sale. So if you have a team of good programmers, you can take away the source code, modify it, and come up with the flavor of Unix. Consider Unix as an ice cream, like how ice cream has various flavors. In the same way, Unix is one having number of flavors, and each flavor is having number of versions. So like that, this thing was designed, and the source code was kept for sale. Now, when the source code was kept for sale, many industry giants purchased it, modified it, and they came up with their own flavor of Unix. There are many, but I'm going to talk about the topmost flavor of Unix which are out in the market. So, the topmost flavor according to hierarchy, the first to come was HP in the year 1984, and their flavor is HP UX. Similarly, following the same footprint in the same year, Apple also came into the picture with their flavor macOS, which we use in uh, what I can say, MacBook Pro and all that thing. MacBooks are available in the market, and the same thing has been compressed, and now it is used as iOS in our mobile phones, in our iPads, and all that thing. So this was also released in the year 1984. Following them, one of the topmost flavor, one of the very, very popular, and one of the, what I can say, giant of all was from IBM, and their flavor is AIX, Advanced Interactive Executive. That was released in the year 1986. And one of the very, very popular, Sun Oracle Solaris. Earlier it was Sun Solaris, now Sun has sold itself to Oracle. So no more it is called as Sun Solaris, now it is called as Oracle Solaris. So this was released in the year 1992. So these are all very popular flavors of Unix that are out in the market, that is available, that is in use in the market. People are using it and it is going on. So if you see them, the features of these Unixes are, they are not generally available for every platform. They are platform dependent. They are hardware dependent. For example, if you want to go for HP UX, then you have to go with HP's hardware. If you want to go with Mac OS, then you have to go with Apple's hardware. If you want to go with AIX, then 100% you need IBM's hardware in IBM P series hardware. Similarly, if you want to go with Solaris, you need Sun's hardware. But as of now, Solaris have been modified in such a way that you can also use it on VMs. But still, for having the optimum performance and optimum results, it is recommended to use the Oracle's or Sun's hardware. So if you see, all these flavors are closed source. It is not open to everyone. Almost every Unix flavor are licensed and commercial products. They are multitasking, multi-user, definitely. All flavor of Unix are hardware proprietary. That means they are dependent on a specific hardware, which cannot be installed on a general hardware. Now, the combination of this software and hardware will make this operating system very expensive. See, I don't know about HP UX, I don't know about Apple or Mac OS, or I don't know about Solaris. But I can tell you, if you want to work with IBM AIX, like I'm working on IBM AIX for almost 9 years, and I know that how expensive setups IBM AIX would be. For example, if you wanted to go for a minimum setup, like entry level basic server of IBM P series, let's say P series 710. So if you want to go for P series 710 entry level basic server, then that server is also going to cost you almost 5 to 6 lakhs rupees in Indian currency. That if you convert in dollars, it may be thousands of dollars. So this kind of setup is quite very expensive to purchase, and not only it's quite expensive to purchase, but the maintenance involved inside it is also very expensive. You need to maintain around 18 degrees temperature around it, and lots of requirements are there. If you don't match that, then the silicon chip and all may be melt down, or something may happen, and that may be burnt out or something like that. So this software and hardware combination makes the total setup very costly. And not only setup is costly, but the maintenance is also very costly. So again, it's a kind of affair which only big companies could go for it. Small companies or an individual is very highly impossible kind of thing to maintain such a setup in their environments. So not only this thing was very costly, but to get trained on this particular concept was again very costly. Forget about maintaining a server, forget about purchasing a server, but assume that if you wanted to go and if you wanted to learn this kind of thing, so even the learning fee because of the setup was quite very high. Because the setup what they use is very expensive, maintenance is expensive, and that is going to increase the cost for training also. So there were lots of costs involved inside it, and which was out of reach of a common man, of an ordinary people like you and me. So in those days, people got frustrated about it that they are having an operating system, a very interesting feature is out into the market, but they are not able to learn it. So in those days, there used to be an organization which is still there, whose name was FSF, which stands for Free Software Foundation. Now, as the name itself suggests, that Free Software Foundation would be providing free software that can be used on any flavor of Unix. Like in today's time, also most open source products are available that you can use it on any Windows flavor or Linux flavor. So these people will also used to do the same thing. They used to design certain software free of cost. Their all product will be carrying a license called GPL, general public license, which can be used by anybody. You can share it or any kind of thing. So these software people thought that how long we are going to work only on software. Let's try to design some operating system which is close to Unix, or which is exact replica of Unix. So they started one project, one movement, which they named as GNU Movement. And GNU stands for Generally Not Unix Movement. So according to this movement, they wanted to make an exact replica of Unix. Whatever is possible on Unix, they wanted to make it possible on this particular OS, on this particular kernel. Many big names did not join this product because of their engagement with higher firms like AT&T and all other. So they did not able to join this project. But young programmers, students were very excited about it, and they tried working on this project like anything. They tried, but only one student from Helsinki University actually succeeded to make an exact replica of Unix kernel. And once this kernel was ready, he named this kernel as GNU kernel. Now, if I go back few slides, you'll see that we have discussed that to make an operating system, you require a kernel. And once you have a kernel, you require some software to add it into it to get your operating system. So as the kernel was ready, FSF was full of software. So what they did, they combined this GNU kernel with number of software, and they came up with first ever free Unix into the market, which they have named as Linux. And the reason why they have named it as Linux, because the fellow who has designed this kernel, GNU kernel, his name is Linus Torvalds. So this Linus Torvalds, what he did, he has built a kernel which is an exact replica of Unix. Whatever you do on Unix is possible on this particular kernel. So after combining some software with GNU kernel, they came up with first ever free Unix, which they name it as Linux, where Linux is also having an abbreviation which stands for Linus's Unix. So again, it is also Unix, but it is not generally called as Unix. It is a Unix designed by Linus, so they have named it as Linux. So the feature of Linux is the first thing. It is open source. There is no cost involved inside it. And the license of that software is again GPL, General Public License. That means you can use it, you can distribute it. The source code is openly available. You can take up the source code, you can modify. You yourself can come up with your own flavor of Linux into the market. And one of the very important feature, it is hardware independent. That means you can keep this particular operating system running on any hardware of your choice. You can use it on IBM's hardware, HP's hardware, Dell's hardware, or your assembled hardware, IBM's hardware, wherever you want, you can put it. You put it on a physical machine, you put it on a virtual machine, everywhere it is possible to put Linux. So what left? As Linux was introduced into the market, it was fire in the market that there is an operating system. There is a big competitor for Unix is out into the market, which is exactly same as Unix. Whatever you want, you can do it. You can put it on any hardware platform. People started to use it like anything. And not only they started to use it, but many programmers, they adopted, they worked on it, and they came up with their own flavor of Linuxes into the market. So this thing was introduced in the year 1991, and from 1991 to 1994, there was almost 400 flavors of Linux out into the market. Such a huge response, such a huge flavors were out into the market. Now, if you see, Linux is exact replica of Unix. Almost 400 flavors are out into the market. It's an open source, hardware independent, many features are there. But still, in those days, it was not used on production environment. It was only used as a personal concept in your laptops and desktops for learning, for viewing, for understanding kind of thing. It wasn't used on production. Why? Such a good operating system, same as Unix, totally free, hardware independent, many features are there, but still why it is not used on production environment, why people were not using it on the server. The only reason why people did not went for it for server was lack of support. Every Tom, Dick and Harry was producing one flavor of Linux, and that was introduced out into the market. But nobody was sitting over there to support the issues and bugs that are arising from it. For example, you are working on IBM AIX. If you face issues with AIX, then you have IBM to support your issues, to answer your queries and to resolve your issues. Similarly, if you have problem on Windows, you have Microsoft Teams supporting over there and fixing the issues for you. But this Linux was out into the market with various flavors, but nobody was having a proper support to help you out with the issues. And that's the reason people was afraid not to use it on the servers. Now people started to understand that the free days of Linux are over. Now Linux would also be a commercial product like Windows or any of the flavors like HP UX, Dell, Mac OS, or IBM AIX or Sun Solaris. But on the contrary, two companies came into the market with a very brilliant idea that have changed the total game of the market. The first to come was Novell, and the product of Novell is SUSE Linux. This was introduced in the year 1992. Following the same footprint, one more company came with the same idea, that was Red Hat, and the flavor of Red Hat is RHL, Red Hat Linux, or Red Hat Enterprise Linux. And one more thing is there, Fedora, on which I'm going to talk in a short while. So these two companies, Novell and Red Hat, came with a very brilliant idea that if you wanted to use my operating system, no problem. Take it for free. We are not going to charge you any money for the operating system. Operating system is free. Even now also, if you wanted to get Red Hat, simply you need to register to your to Red Hat website with your personal email address, and they will allow you to download Red Hat operating system, and even they will give you 30 days of trial support also, so that if you like, you can purchase the subscription. So what they say is that you take my operating system for free, you use it, give it to your friend, whatever it might be. If you have any trouble, if you want any support, if you need regular updates, then purchase the subscription. Otherwise, don't purchase the subscription. So as simple as that. They came up with an idea that use the operating system for free. Whereas if you have any problem, if you want any bug fixing from our side, if you wanted to get the regular updates and all, then you pay me. Otherwise, you don't pay me. So these two companies came with an idea and changed the market's total scenario. And now Linux is like a fire in the jungle where it is used in every place. You just name the technology and I can tell you that Linux is used over there. So following their footprint, many people came with paid support, many people came with free support. Like you can see, there is an operating system called CentOS, which stands for Community Enterprise Operating System. CentOS is an exact replica of Red Hat. How Red Hat is built, whatever Red Hat is carrying, exactly the same thing that would be available in CentOS. And the advantage of CentOS is the updates will also be free. Whereas in Red Hat, if you have subscription, then only you'll receive the updates. But again, CentOS does not have a proper support team to help you in any problems or any kind of bug fix or issues that might be arriving. Followed by that, there are many other what I can say flavors out into the market. Like you are having Debian, you have an African flavor like Ubuntu, one of the very fine operating system. So these are the leading flavor of Linuxes that are out into the market, and there are many other which I cannot list out in this slide. Like you have Kali Linux, you have Mint Linux, you have Puppy Linux, you have Boss Linux, many Linuxes are there into the market. Every day a new flavor of Linux would be introduced into the market. So Linuxes would be coming and going, but these are few of the topmost flavor that are still there in the market and people know that. Also, I was talking about Fedora. See, Red Hat has two flavors of Linux into the market. Red Hat Linux and Red Hat Enterprise Linux, where Red Hat Linux is used for desktops, whereas Red Hat Enterprise Linux is used on servers. Basically, if they wanted to bring any change, especially in Red Hat Enterprise Linux, what they'll do all their testing part on a test project called Fedora, and they'll release that Fedora out into the market so that people may use it, they may give their feedbacks, and on their feedback, either they may be added into the Red Hat or they may discard it from the Red Hat. So it's a testing project. Every month a new Fedora would be released and the old one get expired. No support would be there for the previous version of Fedora. Whereas if you see Red Hat Enterprise Linux is out into the market with different versions. Like you have Red Hat 5, Red Hat 6, Red Hat 7. All of them are still used into the market and still supported by Red Hat. Whereas Fedora, the previous version like 24 version will expire and 25 will release. Then there will be no more support for 24 version. So like that, every month a new version of Fedora would be out into the market. It's just a testing project where all the testing part would be done. And if people approve the change, then they are going to add it into the Red Hat. So these are the top flavors of Linux that are out into the market. Also, let's talk on that which areas Linux is used. Oh my God. This is quite limited thing what I can tell you, because the areas where Linux is used is huge, huge. Wherever you just tell me, I can tell you that Linux is available over there. Like virtualization. Virtualization is actually a method of splitting the physical resources into logical or virtual. See, earlier in very old times, we used to have single operating system and single OS concept, where what we used to do, we used to take one physical machine, and on that physical machine we used to put a single operating system, maybe Windows or maybe Linux, whatever it might be, one operating system. With dual boot you can keep two, but only one can be active and the other cannot be active at a time. So this was the concept. So one machine, one OS kind of concept used to be there. In the same fashion, assume in your environment you require 10 applications to be hosted on 10 operating system. So for 10 operating systems, straight away you need 10 machines to be there in your environment. Now maintaining 10 machine is not that much simple. Assume I'm talking about 10, let's talk about 40 machines. So as the number of machine increases, the complications will also be increased. So maintaining 10 machines, for example, you require rack space to keep 10 machines at first place. Secondly, you need to provide electricity for all 10 machines. You need to maintain air conditions properly available for all 10 machines. You need to maintain proper networking cable connectivity for all 10 machines or maybe 20 machines, however you need it. So in this scenario, the cost involved inside it would go very, very high. To overcome this problem and to reduce the cost, people have introduced virtualization. Now, with help of virtualization, on one single machine, I can split it into several logical machines, or we call it as virtual machines, which can run parallelly in one physical machine. So where on the top of it you can put different operating system according to your need. Like on one VM I can put Windows, on other I can put Red Hat Linux, on other I may put Red Hat Enterprise Linux, or I may be going for one more flavor of Linux like Ubuntu or something like that. So these are the features of virtualization, where I can split one physical machine into several machines, and all that machines would be parallelly working and behaving like an independent physical machine. So now in this scenario, if I require 10 or 20 operating systems, I don't need to go with 20 physical machine. Within one physical machine, I can have 20 virtual machine hosting 20 different operating system and different applications, something like that. Now, who are the vendors that provide this kind of features or this kind of product? So there are some popular vendors out into the market, like you can see VMware, the leading one in virtualization. VMware, you have vSphere, Citrix, you have something called Zen servers, you have built-in KVM inside Linux, and Oracle also have Oracle Virtual Manager, or Red Hat has Red Hat Enterprise Virtualization Manager. So these are few of the leading things that are available into the market. And the kernel, even again this virtualization require an operating system, and that operating system uses the kernel of Linux, or the operating system that they use is Linux. You see, if you want to work with this virtualization, it's all click click world, whichever you go. Click click click, you can create a VM. Click click click, you can increase the size, decrease the size, migrate it from one machine to other machine. All that thing you can do it on a click. But whenever you need to do troubleshooting, whenever you need to fix the problems, whenever you want to install a driver, for example, on VMware, you are installing some NIC drivers or some video drivers or some audio drivers, all that thing requires you to log in into a command line console, and that works on Linux commands. So if I does not know Linux properly, then at that command line, I'm going to have lots of trouble. See, working on that graphically is quite very simple. But when it comes to command line, you must be aware of Linux, and Linux is used built in inside it. The kernel used is the Linux kernel for all the flavors that is kept on the screen as of now. So in virtualization, the base is Linux. Similarly, if we move ahead, you'll see there is a higher virtualization utilization nowadays, which is called as cloud computing. See, cloud, I personally call it as capacity on demand or data center on demand. If I talk about cloud, we need to talk about many things inside it, and that would go a different demo for cloud then, which I don't want it to touch. But if you ask me about cloud computing, I can say that it's a simple method of hosting a data center on internet. For example, I'm a very small player and I cannot host a data center 24 by 7, 365 days in my place because I have lots of loopholes. I don't have electricity redundancy. If electricity is gone due to any reason, then my data center would be down and I may not be able to keep it running. Similarly, I have some flaws in my network or my internet is not that much sufficient that it is guaranteed to be there 24 by 7, 365 days. For any good reason, if my internet is down for 1 hour, then the whole business is going to be ruined out. So there are lots of loopholes that I cannot run the machines 24 by 7, 365 days or applications 24 by 7, 365 days. But there are some specialists or there are some experts who maintain such an environment where they can run their machines 24 by 7, 365 days without any problem, without any flaw. So what they do is they'll propose something to you that you cannot host your applications or your machines at your premises 24 by 7 365 days, but we have an environment that runs 24 by 7 365 days with higher level of redundancy. So what you can do is you can hire the setup from us. We'll provide you whatever hardware you require, whatever setup you require, like how many machines you need, what operating system you need. Host your application at our premises and access it anywhere, anywhere in the world. So that thing is cloud computing, where in that clouds we may be creating public cloud for clients, private cloud for personal usage, internal usage. We have hybrid cloud, which is combination of public and private, many things. So all that thing can be done on various cloud applications that are available in the market. I have used only few of them, very few of them, like Amazon AWS, Amazon Web Services. You have OpenStack, you have CloudStack from Apache, you have vCloud, Cloud.com. Many cloud applications are available over here. So most of them, I'm not telling all of them, but most of them would be using their base as Linux to host that cloud services. Most of the successful cloud things would be running on Linux environment only, where Microsoft also has its own cloud solution, like you have Azure and something, but many of them are still using Linux into the market for hosting your cloud application. So again, again, Linux is used inside it. I'm sorry. So Linux is a thing that is there in every technology. For example, you may be having something called SANs, which are currently used into the market, like anything, storage area network. Like generally, what happens in our working cultures is assume that if I'm having one physical machine, and that physical machine is having a local hard drive. So in that hard drive, you are keeping your operating system, you are keeping your database, you are keeping your application, everything is inside the local hard drive. Now assume if something goes wrong with that physical machine, then the data is stuck inside the machine. Or even dangerous, let's say the hard drive goes crash or something like that, then all the data inside it would get affected. So to avoid this kind of calamities, what people will do is they'll use a special storage setup, which we call it as SAN or NAS kind of thing. So if I talk about SANs, storage area network, on storage area network, you may be having an array of disk. Number of physical disk would be connected to this storage. And from this storage, we'll cut some space, maybe 100 GB, 200 GB, whatever is the requirement. And on the physical machine or virtual machine, you'll keep your operating system on the local stuff on your local hard drive, and all the application related data, database kind of thing, that we are going to keep on the space that is received from SAN. So that is the space that is coming from SAN, and that space, when it reaches to your machine, it would be behaving as a disk. So whatever you are going to keep on this, maybe the database you are keeping, or you are keeping an application on the top of it, whatever it might be, would be automatically stored onto SAN, storage area network. So in that scenario, if the local machine fails or the local hard drive fails, still my data would be safe on the SAN level. Again, there are lots of protection on SAN level, which I don't wanted to talk, like SAN to SAN, there will be replication, mirror view, snap mirror, something is there. Some concepts are used inside it to make it more and more redundant. So there are some leading vendors that are available for the SAN, like you have EMC. In EMC, you may be having EMC Clarion, EMC VNX, and other models that might be available. You may be having IBM kind of hardware, IBM DS storage, something like that. You may be having HP's SAN, HP 3 power, something like that. Or you may be having Hitachi, one of the very leading in the SAN after EMC. So all these flavors they would be using. Again, this SAN will also require an operating system inside it. Like in EMC, we call it as Flare OS. This thing is also built on Linux. And also there is a part in this SAN, we call it as zoning and something. There will be some SAN switches used between it. So even that SAN switches uses the operating system Linux, and most of the people prefer to do that zoning and all kind of thing on command line, which is again a command line that runs on Linux operating system. So Linux is quite very much involved in almost many things. And even if I talk about databases, like you have Oracle database, Oracle 11G, 12C, you'll see that these databases would be installed on your Linux applications, like Linux operating system. Like Oracle has its own operating system called OEL, Oracle Enterprise Linux, which is exact replica of Red Hat. Whatever Red Hat is, they just simply purchase the kernel from Red Hat and they'll release their own name. That's it. So again, it is just a Red Hat, nothing more than Red Hat. So OEL is again a Linux which is used inside it. You have databases, I mean bigger databases like Big Data, Hadoop or something. So even Hadoop uses Linux at the base. Also, not to forget, you have Samsung mobiles, or you have other mobiles that uses Android operating system. Even that Android operating system is a Linux. So this thing, Linux is a roadmap to every technology. Whatever you might be doing in IT industry, the first thing or the base of all, you need to keep it as Linux. So on the top of Linux, you may be building your career, you may be going for many things, and that automatically becomes easier for us. And even if you wanted to learn Unix, the best way to learn Unix is first to learn Linux, because most of them are similar towards each other, concepts and all. So if I understand Linux, automatically Unix become easier for me. So all in all, Linux is very important in nowadays in terms of IT industry in order to build a good career, in order to survive into the market, and in order to go for many things. You have to make your career first on Linux, as Linux is used in many areas. I was just tried to talk about few of them because I know that I cannot talk about each and every concept in detail, otherwise it may make this session for hours. So this is what Linux is used into the market, and you have to learn it. Learn it from anywhere, but a very sincere advice would be learn it, because if you don't know Linux, then you might be suffering at many places. So better to keep it learned before the time comes, and then you have to learn and you have to go for it, something like that. So you have to learn Linux. If not today, then definitely tomorrow or some part of your career you have to come across Linux. So better be prepared before that things comes. And it is a very interesting kind of what I can say operating system to learn. And one more thing, people generally may ask these kind of questions, like, is there any programming involved in Linux or something like that? So as this is just an operating system, like how you maintain Windows operating system, in the same way we are going to maintain Linux operating system. So administration part we are going to cover, and we don't have what I can say any these things, like what I can say programming or something like involved inside your Linux. So this is the thing what I was trying to convey. Now, if you guys have any questions or any queries to put forward, you can put in the chat window. I would love to answer that.